So with that, maybe Jamie, can you kick us off? I'd love to just get your thoughts on what makes you excited about the application of AI for nature.
We might have to share this microphone. And firstly, you don't need to apologize about using slides. I also work with a former Mckinsey, so I'm learning to like slides more and more. I think what I'm most excited about is the ability that we have to build much more intelligent systems that help us manage our complex relationship that we have with nature. So when we think about that, us as a company, the Land Banking Group, we're trying to build these nature operating systems to allow for any corporate, any business, any farmer, any financial institution to manage its relationship with nature in a way that they currently can't or couldn't do in the past. And I'll try and break that down a little bit so I can show exactly where I'm excited. But we think about it, these systems unlocking three core functionalities. Firstly, the ability to measure nature, to understand the health of the assets upon which we depend. The second is to manage that relationship with nature. So depending on the health, depending on the risks and the opportunities, make management decisions about where to invest, where not to invest, how to engage farmers, how not to engage farmers. And the last core piece of functionality is what we call monetize, which is maybe a crude word, but really the step to bring nature into value for companies. So taking nature out of a CSO or CSR cost item and making nature investable, so putting it onto our balance sheets. So those are the three kind of pillars of what we think the operating systems need to provide to the economy. And AI helps with each of those things, as you said, kind of at specific points, but also in the overall management of these systems. In the measure side, I think AI has helped massively with cost reduction. I mean, it used to be costly, timely, hard, static to build these large data sets with regards to nature. And we've seen the last 5 to 10 years, or rather the last 5, a massive cost reduction, which is a combination of AI making data collection cheaper, but also then making data processing cheaper, and also allowing for predictive data points to be developed. So just to give you a couple of numbers on that, I mean, that's with Earth observation, that's a drop in cost of 80 to 100% per data point. eDNA 60 to 80% per data point, bioacoustics 80%, image recognition 80%. So suddenly it's a lot cheaper and a lot easier to get data from nature to stitch together your model. Within manage, I think in the past it's also been hard to take all of these individual data points, look at them side by side and make sense out of them, have a signal out of all that noise. And that's only compounded when you're including financial data from a company, you're using strategic rule sets that come from company strategy, you're including market data, it just gets ever more complex. And again, kind of agential co-pilots, agential AI that can help to pull signals out of all of that noise. There's a massive lift in terms of how we build management platforms. Entity level attribution to that data, I think, is another really interesting piece. It's now possible to, within all that noise and all that data, to pull out really what the signal is that matters for a single entity or for a single company, and that can really help with individual strategies, not just saying the Amazon is going to flip when we're all screwed, but saying if a certain part of the Amazon flips, I'm this much financially evolved. And then very quickly on monetize, I think all of that leads us to being able to bring products faster to market. So to have new financial products that capture the value of nature in a way that we haven't done in the past, bring those much more quickly into our markets. It lowers transaction costs themselves, so more of the value of these investments goes to the people on the ground that are stewarding nature, not to the middle system that's structuring these deals. I think it leads to better pricing, it leads to easier performance, it leads to easier tracking. So I think there's lots to be excited about. That was maybe a long answer to your short question.
Oh, that's great. Maybe Marianne, for you know, maybe start by telling us just the quick one, what you do at Conservation X Labs, and then how have you seen technology and AI get deployed to help halt our biodiversity loss?
Sure, absolutely. So Conservation X Labs is a conservation NGO that is dedicated to really using science, technology, and innovation to change the way we think about conservation. And that's recognizing two fundamental things. One is that, three really, that our efforts at conservation have been in some ways successful. We know that indigenous lands and protected areas, for example, do protect nature, especially indigenous lands, effectively, but they're not enough for the rising tide of pressure that's overwhelming them, really. And so in order to overcome this, we need to think about new tools and use every tool at our disposal. We believe that humans created this problem and humans can solve it, but that we're not going to be able to do that solving in the same way that we've been working for the last number of years. And we believe that technology, including AI, can be a really, really powerful tool in this work. And we have some technologies that we develop in our lab, and we also use a lot of open innovation programs where we're sourcing creative ideas from everywhere. I myself, I'm a conservation ecologist by training. Did my graduate research here in the Amazon in Manaus more years ago than I care to admit, and I've been working in the Amazon for a couple of decades now in different capacities. So I'm not an AI scientist, but I work with a lot of amazing AI scientists, and I'm very much focused on the Amazon. In terms of some of the on-the-ground implications, I just want to give you one example, and I'm glad you gave some of those numbers because I don't have to talk about the reduction in cost. But, you know, over the course of my career, I've really seen us go from being super excited about what we can measure to being completely overwhelmed with the amount of data that we have to deal with, and actually, in some cases, watching deforestation happen in real time and without being able to respond. So I think AI can give us the capacity to understand what we're looking at better and respond much more quickly. And one quick example from Conservation X Labs is we have an AI-enabled camera trap. It actually enables any sensor to do edge AI on the ground. And we're deploying it in New Zealand on islands to track and eradicate rats. So invasives are one of the top drivers of the extinction crisis. The island extinction crisis kind of was part of the birth of the discipline of conservation biology. And with these tools, we can lower dramatically the capacity of the rangers on the ground to actually detect where rats are when the populations are getting lower and there's not that many and you have to get those last few. So for example, in 6 months on one island in New Zealand, our sentinels captured 100,000 images. In those 100,000 images, 45 were rat events. And so that's not something a human can process. The sentinel effectively identified all of those, sent updates in real time to the rangers to set and deploy traps in those areas. So that's just a really concrete example of what we can do.
I live in New York. We have a lot of rats. We might have to deploy it in New York City.
We can talk after.
Exactly.
That would be more like 100,000 events a day.
Exactly. Thank you both for sharing some of those applications. That's amazing. I want to shift from the outputs to some of the foundations. And Scott, I know you're really passionate about this. What do you think do we need to put in place in order to really be able to harness the power of AI for nature?
So thank you for inviting me, and it's an honor to be here. This is my second COP, so thank you. I want to flip the model a little bit. I don't want to ask the question, how can AI help nature? I want to ask the question, how can AI be used to translate what is already known? Translate not only the data that we're getting from the science side, or what we'll call the Western side of the world, but how do we take indigenous wisdom that's been around for millennia and layer it into the data stacks? We have the model upside down. We sort of start with, what does the financial piece look like? How do we architect this stuff? What's the intelligence layer look like? And then as an after effect, it's like we need to build in safeguards. I believe you need to build the safeguards in from the start with the people that are actually on the land, the indigenous people, and their land is sovereign and their data is sovereign. So that is a starting point. It becomes a translation layer between two people that are not communicating necessarily the same. The second piece is that it can't be an afterthought. The data has to be viewed in a sovereign way, so they have sovereign rights. So they don't get to vote like with their hand up. They have veto rights over what it is that they're trying to do. We also are designing the wrong architecture. The architecture we're designing today is like the way we've classically done it in the West, which is big people own all these big data sets and have this intellectual property. It's got to go the other direction. Nobody can own the data. It's got to be open. It's got to be architected in a Linux Foundation type model. Linus Torvalds, who invented Linux, did not become a billionaire by having done Linux. And the Linux Foundation model and Apache 2.0 are ways to govern the process of how you use AI. And then the indigenous data is sovereign. It's their structure. So with those as our precepts, what do you go build? You build a nature characterized foundation model. You start at the bottom with the data sets that come in from geospatial and LiDAR and UAV and indigenous wisdom. All that comes into the data sets. The second layer is you create an ontology so that the data can communicate back and forth. The third layer is a governance layer. So if there's inconsistencies with the data, you know how to adjudicate. And on top of that, you can build the foundation model. So we know what we need to do. We just don't have models that allow trust and transparency and an understanding of where this data is coming from. So that fundamental nature characterized foundational model has to be built before you can use AI for anything.
Thank you, Scott. Once we've built that model, I'm curious, Brennan, you guys are a platform, and you should maybe quickly explain just what you do. But as you think about building a digital backbone that you guys are using for the carbon market, how do you see AI really transforming how we think about carbon markets?
Yeah, totally. Hello, everyone. My name is Brennan. I'm one of the co-founders and CEO of a company called Patch. The really simple way to think about what we do is we help large companies all over the world achieve their net zero goals by enabling them to buy environmental commodities. So that's things like carbon removal and nature-based solutions. That's also things like sustainable aviation fuel. So we do a bunch of nature work, but we also do a bunch of non-nature work. The kind of core unlock for AI, like what AI essentially fundamentally unlocks with our core business, is it removes friction from the system. It really reduces the cost to do the right thing. To make that really, really concrete, when you're a large enterprise, you're looking to deploy a couple $1 million within a specific carbon project, specific climate solution, you're typically going to do some level of technical diligence on that project. Technical diligence usually looks like you need 2 or 3 core pieces of data that Scott was alluding to. So you need kind of the foundational, kind of like natural capital data, quantifying the carbon stock within the location. And then typically you need kind of design documentation. So there's usually, think of this as like hundreds and hundreds of pages of PDFs. And then typically there's some sort of financial model that comes with it. That might be an Excel spreadsheet, might be a Google sheet, might be something like that. Those are kind of the 3 rough kind of ideas. So it's thinking of 2 secondary sources and 1 primary source of data. Historically, to combine all this information to get to a conclusion of, is this a high quality project, or to make a yes/no investment decision, it typically costs someone at Patch somewhere between $20,000 to $30,000 US to do that work. Amazing now at the point that thanks to AI, it costs us about $1 to do that work. And so you still have a human in the loop, and there are still data inconsistencies. So what Scott was mentioning about the governance structure, so it's not that there's no human in the loop, but you kind of have that first analyst type cut that might take a month, 2 months to find all the inconsistencies, do all the fundamental calculations, and kind of re-adjudicate what the technical documentation says. Now you can do that in a minute, and then all the red and yellow flags get surfaced to the climate scientists, and they can kind of take a little bit more of a scalpel-based approach to interrogating the information. And sometimes we might realize that we're actually missing a piece of data. And that's okay, we can go to the supplier and get that piece of information. But there's like dozens and dozens of examples of this where there's some glorified version of copy and pasting information and collecting information from someone. And usually that's required dozens and dozens of people. And now we can basically do that same amount of work across many environmental commodities. And so it's highly, highly deflationary. And so when it's cheaper to do the right thing, more often than not, people do the right thing more often, right? And so how do you kind of keep passing a lot of those costs on to the chief sustainability and chief financial officer so they can continue to invest, and they're not in the situation where they're spending, one of the stats that I really like is one bank was telling me that they spend 30% of their carbon removal budget deciding on how to spend the budget. So we want to make that not that number. We want to make that 3%, right? Well, that's crazy, right? That's completely insane. And so the world shouldn't be like that, and AI helps get a little bit closer.
I love that. Jamie Ferguson from the World Bank on Saturday said it's only going to work if it is better business sense, right? So to your point, like it shouldn't cost that much money. If it's better for the business, then we don't have to worry about really driving the adoption. Marian, I wanted to go back to you. You know, you are sort of at the nexus of translating some of these technologies into real impact on the ground. And so what are some of the learnings that you've had from taking, these technologies and actually making it real and actionable, in the Amazon?
Well, there are so many ways I could answer that question. And I think I'm really glad that Mark is talking about Indigenous collaboration on this panel. I think one of the things that is really, really critical is that we design tools together with the people that are on the ground on the front lines and that actually can help them. I was talking to an environment secretary yesterday. This is not in my notes. And I was telling him about our tools, and he said, you need to come sit down with my team and let them tell you what we have and figure out how what you have could help us with that, because we don't have the capacity to take on another tool. And in the Amazon, many times you have one person or a few people, whether it's a park guard or an indigenous fire brigade, covering tens of thousands of hectares, sometimes thousands of hectares, just areas that are too big to manage. And so we need to develop these tools in collaboration with those end users, because at the end of the day, they're the ones that are making the difference on the ground, so that we're not watching the Amazon be deforested and burned in real time. I want to give another example from our work. This is, actually I have so many examples. Okay. With the point that I just said, one of our examples of not a tool, which I have another tool example, but I have a methodology example, which is the open innovation. And so we work with prizes and challenges. Again, we believe that talent is everywhere, but opportunity is not. And open innovation is a way to incentivize collaboration with people who might not otherwise be part of that conversation. And this is in Western North America, but we're hoping to do this in the Amazon as well. We have a Fire Grand Challenge, and the whole purpose of the Fire Grand Challenge was based on the premise that indigenous, traditional, and place-based knowledge is essential for fire management. I live in California, and this challenge is based in Western North America, but those people are often not in the conversation when it comes to technology. So we developed a model whereby we created a matchmaking process that voluntarily paired technology collaborators, some of which are tribes, because indigenous people have their own technology and their own innovations in science, with place-based communities. And some of those examples are using AI in really creative ways. We have Fireswarm, which is working with tribes and government in Canada to use drones to help the tribes protect their land from fire. We have Vibrant Planet, working also with several indigenous groups in California. We have the Sierra Fund, and both of these are actually decision support tools that use AI, where they're incorporating indigenous knowledge into decision support tools around fire management, but in ways that are done in collaboration with those communities. So I think that's really critical. And you see a lot of that in the Amazon, but I'll stop there.
That's amazing. I love that, and I love how you guys are centering really the indigenous communities here. Maybe pivoting a little bit back more into the corporate space, from the conservation space, Scott, how do you see, what can AI unlock in terms of getting more confidence to investors that want to invest, in nature or in nature-based solutions or the climate space? What do you see here as the unlock?
Well, it goes back to building the core and the fundamental foundational work. At Pachama, we've been doing this for quite a while, using what we use the word AI a lot now, but where it started was something called machine learning, which is how do you learn from the data sets that are sitting. AI has now gone to the next generation, as we're all aware of. But what we found very interesting is when we go to a client and talk about the project that we're analyzing for them using our geospatial work, our canopy height method, and those kinds of things. We can go deeper on that. We're looking at baseline land suitability. You look at additionality, you look at leakage, all these things. And one of the questions that comes up every single time by very sophisticated people is their first question is, where are you using AI? You would think that that might be a good thing. But the scientists are saying, if you're using AI, we don't trust it. Because AI does what? It hallucinates. Why does it hallucinate? Because it doesn't have good data sets. So we built a data model using one little small aspect for our carbon accounting using canopy height. It took us about 6 weeks of training, we call her Gaia, training Gaia's brain so that she wouldn't make a mistake. And the way we had to do that was through the scientists. The scientists had to evaluate all the stuff that she was looking at and all the data to create that validation. That's why when we talk about this earlier, you start with the inputs and you train the foundation model on the inputs. But if the inputs aren't good and aren't scientifically based, you have a problem. We have to get through that step, and we're not through that step yet. Once we get to that step, I'll go to Brendan's comment, that's when you get that order or 2 orders of magnitude reduction of both cost and additional speed, because doing it conventionally can take 6 to 12 weeks. And so we need to use AI to get there, but we've got a long way. The other thing is you can't, I use the term, it's an expression in the United States called, you don't want to boil the ocean, meaning if your idea is going to solve every single problem, it's just not going to work. So you have to figure out what do you want to do first, solve that problem, and then add to that. Now it is moving very, very rapidly. But the other fundamental piece is the data sets now are in silos. So you need to create a federated data model that allows the data to come in for free, and then there's microtransactions when anybody uses it so that that free data can continually be evolved. Because we know that the global biome every year is 140 gigatons. Every year, year after year, same movement. We need to have that same dynamic flexibility in our underlying data sets because the data changes, and that's why the foundation models will constantly be moving. We're not quite there yet. I give it 18 to 24 months.
Thank you.
Could I actually build on that because the hallucination point Scott's making is actually a really, really important one. Because sometimes it may not be immediately obvious, but large language models are primarily probability based, right? So the model is essentially guessing the next character or the next byte that's going to happen. It's just that typically it guesses really well, right? But it's essentially what in the programmer's world is called non-deterministic, which means if you ask it the same question 2 times in a row, it's not guaranteed the same answer will always come out. It might be slightly different. And so there's 2 elements. There's the core foundational data. If the data is not good, then that's obviously an issue. But then the second level is you can essentially have multiple checks and it basically ask models smaller, more constrained questions, typically. And so what you'll see is that, at least at Patch, we tend to ask many more rudimentary or fundamental questions in a row. And when we've worked with our climate science team and when we've realized that they've said, oh, the models, they hallucinate, they don't work effectively, you look at the prompt, the question they're asking, and it's typically like, is this project prone to leakage? It's like a super broad question, like no idea, like it doesn't know what leakage is, it's not trained on the model or the foundational data like Scott's alluding to. And so what you have to do is you have to kind of come up with, what's like the internal algorithm you would run? What are the 25, 30, 50, 100 questions you might ask yourself internally, you don't even realize you're asking yourself? And then those are the prompts, and you essentially have to chain them together to narrow it down. There is also a very interesting cultural thing. We're kind of finally over that hoop, but we had a very similar dynamic of, well, okay, again, we have about half of our OpEx is some sort of climate expert at Patch. And a common question that comes up all the time is, well, I can't use it because it hallucinates. And the reality is it just has to hallucinate less than the best human. It doesn't have to not hallucinate, right? Like the reality is if you're in the heat like this, I've probably hallucinated talking to you. I'm sweating, it's super hot, like I've probably hallucinated, right? But we're not throwing me out, at least not yet. Right, and so it's we ask there's a certain threshold of error. What's the associated error rate? And just like with a major investment, you might have 3, 4, 5 checks, and that might imply a specific error rate. You just have to be that error rate. You don't have to be 0, 0, because humans also hallucinate.
I love that. I've actually never heard it expressed that way, but it's totally true, right? We all make mistakes. Yeah. I would actually love, Jamie. So we just talked about AI hallucinating. That's obviously one of the risks. What are some other risks that you see, things that we should keep in mind as we think about deploying AI?
I feel a bit naked you asking me that question in front of Scott. I think you've done some more thinking on this than I have. I think beyond the end of poetry, beyond the end of human creativity. I think if we don't go down that route, there's lots that there is still to be scared about with AI and to manage these risks. I mean, I think the first one is the fact that we can make quicker and faster decisions doesn't mean we're making better decisions. We've kind of covered that. These models can be not only hallucinate, they can also be overconfident. They can jump between data points and then interpolate in a way that they're kind of making up. So we can't take the human out of the loop. That's one key thing. And we have to find that really nice balance of having enough automation such that we actually leverage the smartness and the intelligence that we have from these systems without slowing them down and having too many checks, without kind of completely removing the human from the loop. And the second piece is on governance, as you've touched on already. Kind of where does the data sovereignty lie? That's one big question. But I think there's also then very clear questions about how you manage the data. I mean, in our company, we're working with 15, 20 food brands. With each have projects in 6 countries around the world. We have data from all of them. And we're running models that are showing, well, how much risk is within those supply chain, how much value could be increased if they invested into nature in a certain area. And if you're not really, really careful, you're going to have data leakage between all of these data sets. And suddenly you've corrupted not only your intelligence system, but you've just lost complete trust. You're making recommendations that aren't trustworthy, and you will lose the trust of your clients and of the farmers and of the indigenous communities on the ground. And I think the other risk, I was thinking about this the other day, and I don't know if this is quite a risk, but I think kind of our use of AI as individuals and also as companies is heavily subsidized at the moment right now. I mean, it's kind of subsidized by the fact that the providers of AI models have raised so much capital, and that's why they're able to survive. They're not surviving off our revenue. We're discounted from the investor lens. So I also wonder what the true cost of using these systems is when that bubble bursts, slows down, deflates, whatever you want to call it. And I think that's a business risk for anyone that's using it that I haven't heard too many people talking about, but I think it's probably quite real. But I'm sure you have some more views on these risks.
I have a lot of views, but I don't want to dominate the conversation, but I do want to add something to what you just said, which is I think we all know the level of energy that the GPUs use, and you've seen the investments that these big tech companies want to make. They're not talking about $100 million anymore. They're talking about $100 billion. Why? They need energy. And that is probably the biggest downside to this whole AI thing, is how do we get through that problem? And I don't have that answer, because in the United States we can add about 1.5% to 2% to our energy grid every year, but AI is demanding between 7 and 9%. So they're doing 30, 40-year PPA forward purchasing power contracts now, just to maintain that orientation. That's an environmental hazard all by itself. And I don't have a smart enough answer for how to get around that one.
I mean, water as well. Water's the other massive
That's the
part
other
of this,
piece.
which is, I mean, Intel's building a plant right now in the Midwest and the North, and they've put a lot of money into it, and they've had to kind of stop it because they're suddenly aware that they might not have the water that they need for the next X amount of years, and they're looking at wetland restoration, not mangroves, but kind of wetland and riparian buffer zone restoration, just to have access to the environmental assets that then runs all these machines. And we're talking about using those machines to manage environmental assets, so the whole thing can be a bit mixed up.
I'm curious, maybe pivoting away from the risks to, if we think about scaling this, what are some, Brennan, I'm super interested from you, what are some of the challenges that you see in scaling AI in the nature space, and what do you see as some of the biggest opportunities ahead for us?
Yeah, I mean, I think it really comes down to what we were talking about earlier when it comes to high quality data. So, we work with around 450 or so different counterparties on the supply side of our business. Not all those are in the nature world, but around 250 of them are. And so these can be really large, sophisticated organizations that are doing some form of green bond or climate finance at like Morgan Stanley. This could be down to like a really small regional project developer in India that none of us have heard of. And what you'll realize is the quality of data that those organizations have is highly, highly mixed. And as a result, there's training the model, but then there's also this idea of context and inference. So basically, once you have the model, you then basically you can give it you can ask it a question, but you can also give it other context to like consider essentially as you answer that question. And what we find is often we're rate limited by high quality context data from project developers in a lot of cases, right? So now, to be fair, that's a rate limiter for a human doing technical diligence as well, right? So it's not necessary to say that that's a uniquely an AI problem. But if the goal is to move and make investment decisions and deploy capital and move more quickly, and having access to the information to make that decision readily at hand is the greatest rate limiter. And so what we've begun to do is we're building more and more capabilities to make sure it's easier and easier, again, to reduce the friction, just to get that data into the system, right? How do we get it in there? How do we make it clean? How do we make sure, the number of like PDFs I get that are like verification report, like 2022 final underscore, like it's just like the quality of data is actually very poor. So in a lot of cases, we actually use AI to clean the data and then include it separately. But the biggest rate limiter, the biggest rate limiter is still going to always be when it comes to leveraging the model, right? Assuming there's energy, which to be fair is a big assumption, but I can't solve that problem right now. The next rate limiter is going to be access to high quality data. But once you get there, then you basically get to the situation where then the opportunity is, I mean, not to be like hyperbolic, but it's almost unlimited, right? So much of the work we do, whether it's setting your strategy, running a kind of a procurement process, doing technical diligence, doing contracting and portfolio construction, negotiation, is really just all laptop work. It's all just pushing bits and bytes around. Our project developer partners are the ones actually doing the hard work on the ground. We're just trying to get them access to money. Basically, we're a glorified money hose, like in the most crude sense, which is not the worst mission in the world, right? If you're funneling the money, it's good people. But a lot of that's rate limited by email, spreadsheet, PDFs, etc. And so for us, like, we're 55 people. I think we can probably triple the size of the business and probably grow headcount only by maybe 5 or 10%, right? And again, those are all savings that are passed on back to the buyer and back to the supplier. So again, reduce that take rate, reduce that intermediation fee, if you will, take more friction out of the system, and keep more money flowing.
Hey, Brandon, real quick. You're in the VCM Plus, right?
No, I'm not actually.
Oh, you're not?
No.
Oh, I thought you were.
No.
Okay. One of the things that the voluntary carbon market is really upside down and broken, just really badly broken. So a group of about, and I was sure Patch was in that.
Yeah.
Anyway.
I got much in the mail.
Well, no, it was. Do you know Alexia though, right? Okay. Well, yeah. So, come on in. I was sure you were there. That we've taken a look that says, look, that market needs to change. So we've a bunch of people, including the VCM Plus group, have formulated a consortium of how do we get all this data to communicate back and forth, and how do we go from this voluntary carbon market to a verified carbon market. And the work that they're doing is engaging in that. So be a place I would go look.
I think, Marianne, you also had something to add.
Yes, and that was actually a great segue to what I wanted to say, which was that just thinking about some of the comments that were being made about the costs, the environmental costs, the subsidies, and the water and energy use, bringing it back to nature on a couple of different fronts. One of the main reasons why we're in the mess that we're in is because we don't value nature and ecosystem services the way that we need to value them in markets. And I think these kind of tools have an incredible potential to actually start to do that monitoring and verification that has been a roadblock in creating the types of markets for either carbon credits or biodiversity credits that can be really robust and that can actually start to have an impact and start to create mechanisms in which we can actually add that value on to the areas that we're trying to protect. And to give just another example, and before I give this example, I want to say in terms of nature data, talking about data quality, we have so much data from nature, but we can't process it or understand it. So another another technology that CXL has developed is called Wildbook, and this has a lot of applications for both science but also monitoring. It's actually using AI to identify individual animals. Around the world, we have a wild book of about 300,000 animals that is being tracked by scientists all over the world, and you just can see how the combination of some of these technologies together can start to create a situation where you can do really, really incredible, robust monitoring and really understand the impact of nature that you're having. And another example the same team with the Wild Book is actually starting to make a Wild Book of trees. Starting in California, which is where I live, we're mapping all of the giant sequoias in California together with the National Park System and the USGS. And not only mapping them, but also giant sequoias, which, as many of you know, are just these incredible, huge, ancient organisms. And there are not that many of them. But they are suffering from bark beetle infestation. And it's very hard to detect that from the ground because they start to die from the top, from the canopy. And the human eye, even looking at satellite imagery or planet imagery or drone imagery, it's too subtle to really detect. So our AI tools are actually learning to detect that change so that they can send rangers to those trees and they can do interventions on those individual trees to keep that from spreading and hopefully save our giant sequoias. So I just wanted to bring it back to the natural world, and because I think it's really important to talk about the mechanisms and the data and the governance and the finance and all of these macro things, but at the end of the day, there's a tree dying or being cut down, and I think one of the biggest challenges that we as a community have is figuring out how to actually get these tools to make a difference on the ground.
You got me excited about the value of your point on the value of nature. I wanted to just share a couple of examples also from our world where I think one of the problems is that traditionally it's been very, very hard to attribute value to individual entities to then drive kind of entity level investment. You have amazing tools like natural capital accounting out there where you can look at a natural asset, monitor its extent, monitor its condition, make estimations of the ecosystem services it's providing. But the moment you move into valuation of those ecosystem services, you're relying on quite disparate databases from reference projects that are valued in a particular way that might not relate to how this natural asset relates to your business model. So I think AI is actually helping us break down that space a lot. To give you one example is from the Amazon. There was a study and a piece of tooling done that we use which looks at correlating soy yields with presence of forest cover. So it just builds a response function between I'm a soy field, if I have forest at whatever distance away from me, my productivity looks like this, or it looks like this, or it goes plummeting. And they built a large model which looked at every soy field in Brazil and then ran deforestation scenarios and looked at what would happen to soy productivity under those deforestation scenarios. And they found, as what we all expect, that soy productivity goes down as deforestation increases. But the really interesting thing they could then do was layer in open source databases and private databases to do entity level, like put that value up a value chain. So they could say, okay, we know that Cargill roughly sources X amount from this region, and here's the effect in that region. We know they sell to roughly these people, they sell to roughly these people. So you can map out where the value sits and make it visible in a way that we haven't been able to make that before. And I think that doesn't say that these investments are going to happen. There's a lot of work that needs to go into that, but you can make value much more visible to individual entities, and that can serve as a basis for having the right governance structures to manage something as big as the Amazon, whereas before it was always too big, too global commonsy, too public goody for us to do anything at an entity level.
I love that example. That's really great. We'll have a little bit of time for questions from the audience. Does anyone have a question for the panelists?
Thank you, that was really interesting. I just wanted to ask Marianne, we're talking about valuing nature, but how do we value the input from the indigenous peoples whose knowledge is so absolutely key in this whole endeavor? And I'm thinking about things like the Cali Fund, there's no money going into that because no companies are willing to pay for the genetic resources that they're using. So you already see it doesn't work.
I wish I had the answer to that question. Actually, I will say that with the Fire Ground Challenge, when we were developing it, I spent a lot of months kind of, part of our goal with the Fire Ground Challenge was to get indigenous knowledge incorporated into systemic approaches to dealing with fire. But my question that I kept asking myself is, how do we do this in a way that's not appropriative? And my answer, which I've come up with, and this might sound so obvious, but sometimes you just have to grapple with it, with things for a while, is that, you know, I don't have to have that answer. The answer is being developed by people like the Indigenous Future Society, another one of our Fire Grant Challenge finalists, who are working with the technology directly and making those decisions themselves about how that their knowledge should be incorporated and in what ways. And I think that one of the things that we need to do better as a technology community is really engage people from the beginning and not just bring in their voices, which are very often absent in these discussions, but actually bring them in as co-collaborators from the beginning. And it's hard to do because there's been so much betrayal, there's so much fear, and there's also really Indigenous and local communities are so stretched, not only for resources, but also for their time. And so figuring out how to work with them in a way that is realistic with their time and human capacity can also be challenging. I'm not sure if that answered your question, but yeah, but I think it's a continuing thing that we have to struggle with. But that co-creation is really key.
I think that's a
Hi everyone, thanks for this panel, very interesting. I was wondering, how do you handle the data confidentiality issue on this kind of topics? You were talking, Scott, about the fact that there will be a platform, you can exchange data, it will be available. You're talking about open source data maybe from such kind. You're just talking now about indigenous people, what about their rights, and how do you handle this? Because it's a very ethical question when you're using IA, and on the servers and where it goes. So I'm working for the French Development Finance Institution, PAINEL. We are using AI on daily basis, but we cannot put confidential information because we don't know where it goes. So it's a real issue for us. We're a bank, so it's normal. But how do you tackle this issue?
Well, that's a very hard problem when the people that are funding these companies that are doing this work require a return on their capital. So one of the things that they look for is, well, give me your intellectual property moat. Tell me how you're protecting what it is you're going to deliver so I make my $1 or $2 or $3 billion. That model's fucked. That's just, can't do that. You need to have it be an open model. You've got to move out of this idea of it's my proprietary data set. That's the, if you don't move that way, you don't solve the problem. The second problem is you don't bring in the indigenous wisdom and the data from the ground in my mind, in a co-collaborative way. It's the data they are bringing in. They have a sovereign right to it. So if they decide they want to remove that data, they have a sovereign right to remove that data. And we have to get, and I don't want to get on a pedestal here, but we have to change the Western way that we've thought about our data and our proprietary in the old, like, Google model or Meta model or whatever the big tech companies are, and move again into a foundation model that recognizes sovereignty of that data. But it needs to be open, so it needs to be transparent. And if you're constraining your particular application stack into your little geospatial whatever or your little satellite information, and you're going to try to sell just that, now you've got, I'll give you an interesting example. NVIDIA, everybody knows who NVIDIA is. Their head of sustainability is a wonderful woman named Tanika. She runs the entire ISV, Integrated Software Vendor Program, for NVIDIA on their AI stack. There's 32,000 companies building AI solutions on their AI stack. 1,500 of those companies are doing it for the environment. And at Pachama, along with a couple of other people that we're working with, we're trying to move in to say, with all you 1,500 companies, let your data be open. and we'll figure out the licensing model as we go. It would be impossible to scale a market if I had to negotiate every data set with every person. Well, I'll rev share with you and you rev share with me, and then, you know, we'll do this counter thing, we'll do a micropayment over there. It's just not going to scale, which is why the voluntary carbon market today is broken, fundamentally. So you just have to relax those old constraints and come up with that new paradigm, starting with flipping the model where the indigenous data set's at the top, not at the bottom. Now, I'm not saying it's easy to do, but I'm saying that's what has to happen if you ever want scale.
Maybe I want to add something from the kind of maybe a different perspective. I don't know if it's opposite or what direction it's coming from, but I think also when we think about how you make these data sets available, a lot of what I think about is how companies are investing into nature to mitigate risk. And so if you have open source nature data that anyone can look at, does a Nestle, does a Unilever, does a Cargill want that open source data such that anyone can see if their supply chain is really risky? Do they want their bank to be able to very, very easily do a risk analysis and come in through the front door with their guns blazing because they're suddenly much more risky than they think they are? So I think there is, if we want this to work, not just from the kind of sovereignty and the equality of data inputs to these models, but also then to not have unintended outcomes on the other side of where it gets used. I think there needs to be some governance system that's created to allow for a safe space for where this data can be made public and used, and we don't get slapped over the wrist straight away when we figure out that we're sitting on much more risky assets than we thought we were. I don't know what the solution is there, but I think that's something that I see blocking everything.
I agree 100% with that. And there will be bad actors. There's just going to be bad actors, and that's the price.
I think one other thing that's important is when we're talking about indigenous knowledge, which I'm glad we're talking about it, but it's just for non-indigenous people to educate themselves about what these principles are. There's, many of you probably know the FAIR principles for open data. So there's also an aligned set of principles called the CARE principles that were developed by indigenous people. And there's also an indigenous data sovereignty, I think, center and framework and recent publications. And so it's not up to them to educate us about, what these principles are. We should do that on our own.
Super. We probably have time for one other short question if anyone else has a question.
I have a quick thing to add, which is one more thing that might be relevant to some of what you've been talking about, what you were talking about, supply chains. We have there's the Task Force for Nature-Related Financial Disclosures, TNFD. So Conservation X Labs actually has an open challenge right now. I'm going to give a little plug. I think it closes sometime in December, and it's for tools for small and medium enterprises to be able to better track, understand their impact on nature and also their dependence on nature. And so, share that with your colleagues, and we hope that we can incentivize more of these tools to actually make that impact.
That's amazing. Maybe before we close, are there any other closing encouragements as we all, continue here our time in COP as we think about nature and keeping that front and center?
I mean, one of the common, and it's coming up here a little bit with the open data conversation, one of the most common themes I've heard over the last couple of days, which I think is particularly unique, is actually how partnership oriented a lot of my conversations have been. So this is my fourth COP. So my first was Glasgow, then we did Sharm, then I didn't make it to Azerbaijan. But when I was having conversations in Dubai and Sharm el-Sheikh, it was very oriented around, we want to do all of our own homework, modeling, diligence, whatever it might be, in-house. And now I've noticed, I think a lot of folks are kind of having this realization that, to go fast, go alone. If you want to go far, go together type model. I think there's a lot of other ways to partner, right? We talk about open source. I think that's really interesting. That's not the model we use at Patch. We use kind of more of a give to get model. So we're very explicit, like your data, if you give it to us, it's going to get anonymized and blended, but you get access to that result for free. So you get value, you give value, you get value, right? There's the open source model, which is also great. I'm a big Linux user as well, as a programmer. But I think there's going to be a lot of really interesting partnership models that kind of arise that are AI enablers. And I think regardless of whether you kind of fall in the more open source or closed source or whatever it might be, having many organizations kind of not just competing, but existing to kind of keep the system in balance, I think is healthy broadly, right? I think what Scott was alluding to, particularly with like Meta and those types of organizations, you don't want to have some sort of like monolithic organization. You don't want one LLM company. Like that's really bad. You want to have 5, 10, 15, 20 to have them all kind of keep one another in check. But there's been a huge focus on partnership, which as an ecosystem organization where we basically just connect partners together, it's been really great, really exciting, very optimistic.
Thank you. Anyone else? Otherwise, thank you so much for coming to our panel. I hope you enjoy the rest of your day.
Stay cool.
Stay cool, exactly.